All right, guys, we're looking over problem number 4 on 3.11. So 3.11, we're looking at problem number 4, 8v squared plus 8v minus 48. So when we factor, the first thing we need to look for is a greatest common factor. And again, the greatest common factor could be -1 if the first term is negative. Here, our greatest common factor between 8v squared, 8v, and 48 is 8. And if we divide the 8 out of all three terms, we factor it out. So, yeah, so this is the homework problem. So 8v squared, when we factor the 8 out, is going to become v squared. Plus, we factor the 8 out of 8v, it's going to become v, minus 48 divided by 8 is 6. So that leaves us with 8 times v squared plus v minus 6. So that brings us on to step number 2. Step number 2 is our two sets of parentheses with 3 spaces. Third step's find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. So here the third term is negative, so our signs are opposite. Step number 4 is the factors of the first and third term. Our factors of v squared are just v and v. Since there's not a number in front of v squared besides 1, it's going to be v and v. Our factors of 6 are 1 and 6 or 2 and 3. We'll do 2 and 3, and I'll put 3 first. And when we check this here, v times -2 is -2v. 3 times v is positive 3v, so plus 3v, giving us a positive 1v, which is the middle term we wanted. So these here are our correct factors. Questions on this here? Questions on anything we've done so far? Okay. Any other questions on the homework? All right. Now, what we're doing today is more factoring, but specifically we're looking at a certain type of factoring. And what it's called is the difference of two squares, or difference of perfect squares. Difference of two squares pattern. And what it defined as is a squared minus b squared is equal to a plus b times a minus b. And the reason this works is that our two terms are perfect squares. We can rewrite them as an expression times itself. So x squared minus 9. Well, x squared is just x times x, or really x in parentheses squared. 9 is 3 squared, 3 times 3. So according to the general theorem, a is going to be x, b is 3. So it's x plus 3 times x minus 3. That's it. Now we can factor it like normal because we had one on Friday, our x squared minus 25, and we factored it. It will factor the same as normal, but if we notice that it is indeed a difference of perfect squares, we can kind of jump straight to the factors. So if we look at this first one here, x squared minus 25, we do have a difference because there are two things being subtracted. Now the question is, are they perfect squares? So x squared is what we can say it is x squared, because x times x gives us x squared. What times itself is 25? 5. So we could rewrite this as x squared minus 5 squared. So according to this here, a is x, b is 5. And according to the general theorem, a squared minus b squared is equal to a plus b times a minus b. Well, a in our case is x, b is 5, so how would this factor? This would factor too. X plus 5 times x minus 5. Mhm. Now, if there is a greatest common factor, we can factor it out. And sometimes we'll have to, but this one here, we didn't. Questions on this here? But even if we didn't see the difference of perfect squares, we can still factor it with the same steps we had before and get there. Okay. 4z squared minus 1. So if it's a difference of perfect squares, we need to be able to write each term as an expression times itself, or an expression being squared. And we know that it is a difference. So two terms being subtracted, difference of perfect squares. So our first term, we need to determine if it is a perfect square. Now what times itself is 4? 2. What times itself is z squared? Well, z. Because 2z squared, 2z times 2z will indeed be 4z squared. Now what times itself is 1? 1. Interestingly enough, 1 is the only number we can take the cubed root, the third root of it, and the square root and get the same number. Unless, yeah, 0. 0 is the only other one. Yeah, those two. Now, a squared minus b squared is equal to a plus b times a minus b. So this here would factor to what? 2z 1 times, or we could say 2z minus 1 times 2z plus 1. We could put it in either order. Still the same thing. Questions on this here? These, again, end up being some of our favorite factors, or factoring these, because they work out so nicely. We ready for the next one? X squared minus 64. So x squared would, in the general form to get a and b, we would have x squared. Not 8. Mm-hmm. 8 times 8. So if we divide it by 2, yes, it is 32. But 8 and 8 give us 64. Now there is no greatest common factor. One of the big giveaways is the fact that number in front of x squared is just x. It's 1x squared. Now how would this factor? It would be x 8 times x 8. Mm-hmm. I mean, if we wanted to, we could say x minus 8 times x plus 8. Both of those are the same. Order for these two doesn't matter. Mm-hmm. These are kind of nice, yes?
Yeah.
Yeah.
Oh, then there's a little bit harder.
A little bit. We ready for the next one?
Yeah.
So x squared minus 36 is, we do have a difference. X squared is perfect square 6, yes? So how would this factor? X plus 6, x plus 6, x minus 6. Yeah. And one way, if you're not for sure, especially with the number or one of the numbers, if it is a perfect square, the calculator, we can just take the square root of it. Because here the square root of 36 is 6. So the calculator can check and at least tell us what the perfect square is. Mm-hmm. This looks a little different, yes?
I mean, look, this looks.
But you could just flip it the other way and it'd still be the same.
Well, we could, or we can just leave it as is. Because again, difference of perfect squares. It's a subtraction, and our two terms are perfect squares.
Order doesn't, it goes in, doesn't really matter as long as.
A little bit, yes. Because the difference in what's going to be here is the sign. Because here, our a term, 10 squared, would be 100, yes? m squared is our b. So if we factor this, what would we get? 10 plus m times 10 minus m. Now, if you had flipped it and put the m first for the 10 plus m, it wouldn't make a difference because 10 plus m and m plus 10 are the same thing. However, 10 minus m and m minus 10 are two different things. So this would be the correct answer here. Now, if we wanted to put the m first, it'd be negative m plus 10 times m minus 10. The reason we have the negative out front is I have to change this here, so it would go to negative m plus 10 to negative m minus 10. Because we flip it, the m's negative, so I pull it out. I factor that negative out, which makes the m positive, but the 10 has to go from positive to negative. Does that make sense? So, I mean, for all case and purposes, since it doesn't matter that m is positive or negative, we can leave it alone. Just do 10 plus m, 10 minus m, bless you. Does that make sense? So even though the variable ended up second, we just put it in the second spot. Any other questions on this here? Make sense? 9n squared minus 16. So if we did this out, so 16 squared is 4 squared, yes? 9n squared would be what? 3n squared. Yeah, so it'd be 3n, 4 times 3n, 3n plus 4 times 3n minus 4. That's it. Now, if you end up switching the variables, if for some reason you wrote it as 3x plus 4 times 3x minus 4, it's the same thing. I'm not going to count off because you switched back to x. If I don't watch it or pay attention, I normally default back to x too. But questions on this here?
Does it matter if the minus plus 7?
So putting the plus or minus, it doesn't matter the order. 3n minus 4 times 3n plus 4 will give us the same thing. And really all these here, we haven't had one that has a greatest common factor. And that's fine. Neither is this one here. But if there is one, we can factor it out. Because again, this is where sometimes it gets not complicated, but sometimes we'll have the correct factors. But according to the instructions, we have to do what? Factor it completely. If there's a greatest common factor, it's not considered completely factored. 16h squared. So it'd be 4h and 4h and 4h, yes? Perfect squares for 49. 7 and. So 16h squared minus 49 is 4h plus 7 times 4h minus 7. Or we can say 4h minus 7 times 4h plus 7. Questions on this here? Are you ready for the next one? 25b squared minus 36. Well, 25b squared is going to be what? 5b quantity squared, so 5b and 5b. How about 36? So we have 5b plus 6, 5b minus 6. Questions on this here? Now we didn't, I'm going to put one more in. Because let's say, because 64x squared. I'm going to need a calculator. Not what I wanted. Okay, so what times itself is 64? So we could say 8x plus 8x minus, yes? What times itself is 144? 12 and 12. So this one's not on the paper. Now, okay, so that worked just fine, yes? Okay, let's look back at the starting problem. Is there a greatest common factor between these two terms? What is it? Because 2 does go into both terms, yes? I think. Does divide by 8. 8 and 8. $16. Let's see here. 144 divided by 16 is. So again, we could start looking at our factors. So 64, 1 and 64, 2 and 32. 3 doesn't work, but 4 and 16. 5 doesn't work, 6 doesn't work. 8 and 8, I think is the next one. 144. So 1 times 144. 2 times 72. 3 does work. Be 3 and 48. 4, 36. 5 doesn't work. 6 does. 24. 5 does, or 7 doesn't work. I think 8 does. 8 and 18. And 9 times 16. Well, I was just looking at all the factors because this, again, a way that we can get to that. So what's the biggest number that goes into both of these? 16 is the biggest factor of both. That's one way to get to the greatest common factor. So what we could do is actually factor the 16 out. So I'm going to erase all this here. So we could say 16. If we divide 64x squared by our 16, we have 4x squared minus 9. Okay. So what times itself is 4x squared? 2x and 2x are plus, minus. What times itself is 9? So really, 64x squared minus 144 is 16 times 2x plus 3 times 2x minus 3. Say we missed that. Let's look back over here. So say we missed the 16 at the start. We factored it to this here, yes? Our first set of parentheses. There's a greatest common factor of 4, yes? I can factor it out. 4. And when we factor the 4 out of 8x, we have x plus 3. And then in the other one, we also have a second factor of 4 that we're factoring out, which would give us So even if we didn't see the greatest common factor at the beginning, if we notice it at that second step, we can factor it out of both, and we get back there. Does that make sense? Yeah. Yes, sir. What's the greatest common factor between 8x and 12? What number will go into both 8x and 12? Higher. Because 8x divided by 4 is 2x. 12 divided by 4 is 3. But we can also do it with the other one. So we get the two factors of 4 out front. And since we're multiplying all this together, our 4 times 4 is 16, giving us 16 times 2x plus 3 times 2x minus 3. Now, if it just asks us to factor it, this here, 8x plus 12 times 8x minus 12, is indeed factored. If it asks us to factor it completely, then we're needing this here. That's the big difference. The 8x plus 12 times 8x minus 12 is indeed factored. Factored completely. There's no like terms, nothing in common. We need it all the way down. Either one of those works. If it says completely, we need it at the end. Are you ready for the next one? Use a special product pattern to evaluate 54 squared minus 48 squared. Well, they gave us a and b. Because a squared minus b squared is equal to b. A plus b times a minus b. So a in our case is 54. Well, luckily, so 54 squared is 54. It didn't actually, we're not having to do anything to it. Now 48 is our b. So according to the special product factor, our difference of perfect squares, we can take 54 squared minus 48 squared and rewrite it as 54 plus 48 times 54 minus 48. Now 54 plus 48 is to carry the 102. 54 minus 48 is the 54 plus 48 is going to be 102. 54 minus 48 is 6. And we multiply this together. And get 612. Well, it's not so much that they just didn't give us 54 as a square. Because 54 squared is 2,916. So since they already wrote it as a squared minus b squared, a is 54, b is 48. Yeah, because 54 squared minus 48 squared is indeed 612. All right. Yes.
If I tried, I could.
We ready for this one here? Okay. So first thing we can do is write it as 68 plus 62 times 68 minus 62. 68 plus 62 is 130 times 6, 0. Questions on this so far? One more of these, I think we've got it. Yes? All right. 36 squared minus 34 squared, yes? Okay. I mean, yes, we can do 36 plus 34 times 36 minus 34 and go through that steps. It's all numbers. 36 squared minus 34 squared.
Well, you can just straight up put these into the calculator and
Yes. Now this method's helpful if we don't have one. It makes actually solving this a lot easier. We don't have to do the squares of each and then subtract. But the calculator will do this just fine. That's it. 3 through 12.